Hi, everybody. This is Professor Dan at the University of Colorado Boulder. And in our next, well, maybe this is our first. We're building a truss here. And before we build it, we got to design it. And there are some tools that we can use. So there's a tool called MD Solids that somebody else puts out. But we have a little MATLAB program that we can use to help us build our trusses or help us design our trusses so that we build them better. So I'm going to walk through how to use this, and I'm going to use a truss that doesn't meet the requirements of the assignment. So everybody has to build their own truss. They don't have to worry about whether their truss is better than mine. This one wouldn't even work to meet the goals of the assignment, but it's a great place to start. Um, so how do we fire up the program? We type in truss GUI or truss GUI, truss graphical user interface, and hope for the best. Hopefully this is going to work. All right. So first thing we have to do is define our horizontal spacing. And this is where we actually have to give it some thought. So we need to have a truss. And so before I even open this program, I kind of had an idea of a truss that I want to build. And I outlined how many points I needed and where those points needed to be. And this is where you kind of give yourself a grid. So you have to make sure that your points are on the grid. So in my case, our horizontal spacing, let's see, I wanted 2.75, that was the size of my grid, and I wanted 8 total spaces. So if you multiply 2.75 times 8, you can see that that's 22 inches. And that's good because that's what we said we needed our truss to be. It needed to be 22 inches, and 8 horizontal spaces is what I need. Um, my vertical spacing interval, I did some math and I need this to be 9.53 inches. And I actually only need one total vertical space. I have a really simple truss. I made it really easy. But basically, before you even get to MATLAB, draw out your truss, figure out where your nodes need to be, and make sure you can put them on your on a grid. So the first thing you do is you kind of have to make yourself this grid. So you got to give it some thought before you even get to MATLAB. Then you hit OK, and look at that. So we go up to 9.53 and we go over to 22. A couple little nuances with this program. The first thing I like to do is just go down in order: edit members, edit support, edit loads. So edit members is basically like add members. So I'm going to hit edit. It says click 2 points to create a member, retrace a member to delete it, and press return when finishing the truss. That's actually enter. Make sure you hit that button, enter, otherwise you're going to crash the program. All right, so let's go across the bottom. So my truss just went from 0 to 11. Oops, I crashed the program. What a bummer. Let me try it again. So every so often, this crashes. So my horizontal spacing was 2.75, no big deal. I had 8 horizontal spaces. I had 9.53 and 1 vertical space. I hit OK. Hey, we're back. I click Edit Members. So I go from 00 to 11. Hey, look at that. When I add it, it pops up and it snaps to the grid I create. So what I did is I basically made a truss with all equal 11-inch members. So all of our members are 11 inches. And so you can see that my 11-inch member only goes up to 9.53. So there, I think I'm done with my truss. I hit enter and it says, uh-oh, my truss is unstable, because it is. I need to have a member going across the top. So the maker of this program was really kind of nice. He made things so that if we made a mistake, it would help correct, but we just hit OK, sure. And I need to have that member going across the top, otherwise it would fall. So now I need to make sure I hit enter, so I do. I click edit supports, so I edit my first support. There we go. It adds the pin first and then the roller second. So I'm going to add my supports at 0 and 22. I'm going to click edit loads. So I want them, I'm going to say I'm going to apply the load right at the middle here. I want 0 in the X and 1.5 in the minus 1.5. So going down in the Y sounds good. There we go, and it's there. And then I can click, oh, this is the thing. So when I'm done, I got to hit return, otherwise it's not going to work. So this is the easy one to mess. So again, hit return. Now I'm going to hit analyze. Doo, doo, doo. Hey, look at that. All right. So red compression, see how it's negative? Those are our members in compression. Blue is in tension, and those ones across the bottom, that's like a darker blue. I guess it's a lighter, it's less, I don't know why it's darker, but it is, and no big deal. So this is how we can have MATLAB. And so that's the thing, it's not the easiest program in the world, but at the same time, it saves us a ton of time, because if I wanted to change things, I don't actually have to build it and change it. I can do some rapid iteration with MATLAB. So that's how we use this. And then we'll take this drawing. So I always say you should save your truss and take a screen cap, because you're going to put that into our next level of analysis, which is the Excel. So having this MATLAB, we would go into Excel and start doing these. These are just the forces. So if we had a load of minus 1.5 kilonewtons or minus 1.5 kips, so 1,500 pounds, this is how many kips we would have. We would have, that would be 866 pounds. But what we care about is not necessarily the forces. That's the first step. What we care about are the stresses. So we'll take what the forces we get in MATLAB, and then we'll go and we'll actually look how to take these forces and do a stress analysis using some Excel. So that'll be the next video. All right, everybody. Hope you have a great day, and we'll see you soon.